Hi, welcome to our Tech Talk on Playback, a Google Chrome extension that allows friends to watch and comment on videos together remotely. This is the final presentation of our Code Lab Summer 2020 internship project, showcasing what we've accomplished over the course of these 4 weeks. Here's a quick overview of our presentation. We will discuss the issue of socialization during the current pandemic, our one of many possible solutions, how we went about building our project, problems we faced along the way, and lastly, our future vision detailing potential add-ons we'd like to include had we continued the project further. Our project is addressing the issue of limited social interaction due to the ongoing pandemic.
As more and more interaction migrates to the web during quarantine, people are seeking different ways to socialize and to have fun with each other. Online video viewings are often divided between platforms. One, such as FaceTime for enabling interaction between users, and another, such as Google Chrome for watching videos. Otherwise, they are restricted to one website, such as Netflix.
Our project offers one way to increase and facilitate digital socialization in a new way.
We wanted to build a single platform application that would allow users to socialize in real time across the web, regardless of which website they were using. So we built a Chrome extension that allows friends to watch and comment on videos remotely together. So unlike Netflix Party, which is restricted to Netflix videos, our extension is enabled for all HTML5 videos. Users can pick their usernames and add themselves to chat rooms, and these comments are then logged to a database for future viewings.
Moving on to how we actually built the extension, we first began by creating wireframes of how we envisioned the application and what the user flow would be like. This helped to guide and visualize the various components and functionalities we were trying to build. During our first week of ramp-up, we all familiarized ourselves with the basic concepts of how to build a Chrome extension. Every extension needs a manifest script, which includes pertinent information regarding the details and capabilities of our extension. We also needed a content script, which would run within the context of web pages to interact and make changes we need to enable our extension. Everything else was not needed for the scope of our project, but offered additional capabilities had we needed them. Starting with the front end of our Chrome extension, these are the files needed to enable our interface. This is another diagram to depict how the front end of our extension is broken up within these files. In the manifest, we define our extension, giving it a name, version, and even description. We also need to include the names of the content script and CSS files we are using so that they all run in conjunction with one another. In the content script, we inject all of our HTML elements, including the chat box and enable button, into web pages with videos. We do this by using DOM methods to get the object for the body of the web page and insert adjacent HTML before the end of the object. Now that our HTML has been added to the web page, we can use other DOM methods and properties within the content script to create functions that will enable users to interact with the interface objects. When a user clicks the Enable button, the chat bar appears and the user can begin commenting, opening and closing the chat whenever they like. And lastly, we include a separate CSS file to style all of our HTML elements and even manipulate the appearance of web pages. This is made possible because within the ejected HTML in our content script, we include a style tag linking the HTML to the style sheet in our extension. Now, when a user hovers over a video, the video is highlighted and an Enable button appears, giving the user the option to choose which video they'd like to start a chat session on.
Asynchronous real-time chatting was enabled using the socket.io JavaScript library, which was accessed via API. By using Node.js, Socket.io, and Express, we built JavaScript functions that would handle communication between two machines. Once users select their username and room, Socket is enabled. So a user's name, their current time, as well as their chat messages are emitted to other users in the private chat room. Heroku, which is a platform which simplifies the deployment of applications onto the web, was used to host the Socket.io functionality, and it enabled transmitting of information between machines.
In order for users to review and play back their comments from past sessions, we needed to store their comments in a database. For our app, we decided to use Heroku to host and serve our database's API endpoints, and MongoDB as our database framework. MongoDB is a non-relational database that stores data in the form of documents. Non-relational databases are great for organizing and working with various types of information. Our Google Chrome extension interfaces with our live site to interact and manipulate the data stored in the cloud. Our site uses Model View Controller architecture to organize the data and serve the views. While the site does feature a GUI, it is primarily an API for our app. The site's two main API endpoints are API v1 comment new for creating new comments, and API v1 session unique for checking if the session identifier already exists in the database. When designing our database, we paid special consideration to the entities that our database would store and the relationships between them. We decided that users would create sessions as well as comments that would be attached to a session. Each comment would have a timestamp associated with it that would keep track of when the comment was submitted during the session, as well as other information, such as the username of the commenter. While users do have usernames, we ultimately decided against creating user documents in our database, which provides a more casual experience for the user. Finally, we utilized the Heroku add-on MLabs to visualize and manipulate documents during development.
Typically, Chrome extensions can't be developed in Node. Services such as Browserify can help transform Node-required modules calls into bundles that can be served up to the browser in a script tag. Local servers also cannot be created inside Chrome extensions. So the application server was hosted on Heroku, and the Chrome extension listened to messages transmitted through the server.
Like in any project, there are always obstacles and unexpected problems that arise, which may cause initial frustration but ultimately lead to valuable learning lessons. One issue we faced early on in the project was getting used to communicating with one another through digital means. Because this was a virtual internship, there was no in-person meeting or working. We had to be proactive and alert on our shared social apps for communication. At first, it was not an easy transition, but after discussing it as a team in our first retro meeting, we quickly formulated ways to encourage and open up communication. We started doing daily stand-ups and implemented collaborative work times, which really helped to improve our team communication. Another problem we faced was getting familiarized with the specific rules and methods used to build Chrome extensions. There was a bit of a learning curve for everyone trying to understand and adapt to these rules, and because of this, we decided to first build our web app based on a single embedded HTML5 video rather than going straight into making the extension. We figured we could just adapt whatever we build and make it work as an extension at the very end. This caused blocks towards the end of our project when we were already pressed for time. Luckily, we were able to successfully break through on most fronts with the exception of the backend server. Since there were 3 of us, we all took on different pieces of the project. There were 2 of us working on the front end, and it went smoothly for the most part. However, when connecting our pieces, it proved a little more difficult than expected. One of us could not access the socket account the other had made, making it difficult to visualize and apply needed styling fixes. This caused a block until one person could pull the other's work and single-handedly integrate it with one another, but eventually they were combined. To conclude, thinking about the future and if we had more time to continue to build upon our project, there are many additional features that could be added to improve upon the overall user experience and value.
In the future, we will focus on security. So our extension, Playback, currently enables users to join any rooms. So random users can just hop into a room and other users lack the ability to remove them. We will add that functionality in the future. Ideally, we can also add a password functionality upon trying to enter a room, as well as generate unique hexadecimal or string room IDs for the user, rather than relying on user-created room names to ensure that random users cannot just easily enter a room. Aside from that, users should also have the ability to customize and change their profile after their username has been selected, and have elements in the chat box also update to reflect those changes. The extension currently asks users to enter their chosen username only once.
Moreover, the main goal is to eventually be able to publish a working model to the Google Web Store, which people could actually use. Another feature we had in our backlog/product roadmap was the idea of having the comments appear based on the time they were made in the video, rather than just having all the past comments available in the log all at once. Having the ability to like comments as well as reply to comments in threads is another great way to improve the extension for the future and allow users to interact even more. Adding a comment filter could also be of value, allowing users to sort comments based on different factors such as most likes or most recent comments. Ideally, our extension would encompass all these capabilities and much more, as there are so many ways that people can interact and socialize over shared media. Given that we are still in the midst of a global pandemic, this could be a very useful and popular tool for many people still stuck at home. Here's a link to view our work on GitHub. Please feel free to reach out to us with any questions or feedback, whether related to the project or not. We'd love to connect with you all. Thank you for watching.